This video will help you understand the relationship between radical expressions, expressions with a radical symbol or a root symbol, and rational exponent expressions, such as x to the 1/2 or x to the 1/3 or x to the 3/2. The biggest thing we need to know is that the two ideas, the radical and the rational exponent, essentially mean the same thing. For x to be to a 1/2 power, that denominator, that 2, is really just indicating the index of your radical. So a 1/3 exponent is the same thing as a third root. A 1/4 exponent is the same thing as a fourth root. Or as we would say, x to the 1/n is the same thing as an nth root. Now that means that if we have something like 3/2 up in the exponent, then instead of a 1, which would normally be the exponent for all these x's inside of your root, now we have a 3. So I need to know what to do with the 3 and what to do with the 2. The 3 on the top is still a normal exponent. It's saying x to the 3rd, or to the 3rd power over here. Whereas the bottom, that 2, remember, is a square root, as we showed on the left. So this next example, 3/4, means that it's the 4th root of x to the 3rd power. And realize that it doesn't matter which of those you do first. Both of them are powers, so as far as PEMDAS is concerned, they both fall under the exponent rule. So the 4th root of x, then to the power of 3, is the same thing as x to the 3rd, taking the 4th root afterwards. And again, the main idea is m on the top is still an exponent, whether that be under the root or outside. N is now the index. So the nth root of x to the m, or the nth root of x, all of which is to the m. Now, one major thing we want to do before we do too much with these roots is just be able to convert back and forth. So taking a radical expression, as we have over here on the left, and rewriting it in rational exponent form. So if we think about it, d is still our base, 2 is our exponent, so it's still d squared, but instead of just being over 2, or to the second, 2 is now divided by our index, our 7. So d to the 2/7 is the same thing as the 7th root of d squared. 8 to the 2/3 is already a rational exponent. So we need to rewrite it in radical notation. Realize that 3, again, is going to indicate a 3rd root. The 8 is still our base, and the 2 on the top is still our exponent. So the 3rd root of 8 squared is a perfectly good way to write that. You could have also written the 3rd root of 8, the quantity squared, both of which would actually come out equal to 4. But remember, when all we're doing is rewriting, we just want to rewrite it one time and call it the answer. Do not go trying to find a simplified form. To do that, normally the book will ask you to evaluate the expression. So there we're saying in a 4th root of 256, well, we could change that to 256 to the 1/4 exponent if we want, or we could just evaluate it as is. Normally a number under a root is not terribly hard to just work from directly. Now we can do the old-fashioned break it down. Remember, like the great rappers of the 80s, break down those roots. So 256 is really 16 times 16. 16 is really 4 times 4. And again, 4 and 4. And if you wanted to, you could say, well, hey, I've got a group of 4 4s in there. Remember that for an index of 4, I'm looking for a group of 4. So I could say that the 4th root of 256 is 4 directly from this point. Or if you want to break it all the way down to prime numbers, you got a pair of 2's here. You got another pair of 2's right there. Another pair of 2's. And a final pair of 2's, which means that 1, 2, 3, 4, I got a single pair of 2's, and 1, 2, 3, 4, there's another pair of 2's still multiplied together. Notice no leftover prime numbers, so everything's outside the root, and 2 times 2 gives you 4. Again, not all the problems are going to take you making a factor tree. You could have also done that problem straight on your calculator. Again, if you're evaluating, you really just want to find the value of it. So you could say this control caret And notice it's going to give you the little index button then. Don't just press square root. We need the fourth root. Just put that little 4 up there of 256, and we can check that our answer really does come out to 4. I don't think we'll need our calculator for the next one. Remember that a 1/2 exponent is really the same thing as the square root of 49. Notice that that's inside the parentheses, so that negative on the outside, that'll be the last thing we do. I'm just going to keep leaving that outside of the function here. And the square root of 49, remember, is 7, and a negative 7, therefore, is our answer. Third root of negative 8 is really asking you what to the third power would give you negative 8. And we'll deal with that fifth power here afterwards. Well, if you think about it, negative 8 is really just negative 2 to the third. Well, third root, third power, you can cancel those two things away, and you'll end up with just negative 2. But don't forget, that whole quantity was to the fifth power. So a negative number to the fifth power stays negative, and 2 to the fifth power is 32. And there you go. And finally, 3,125 to the 2/5. Again, if that 2/5 exponent looks a little bit tricky, go ahead and think of that as the fifth root of 3125 squared. I'm going to do the fifth root first because that'll give me a smaller number. So again, if you break down that 3125, I believe that's 25 times 125, which is just 5 and 5. 125 is 5 and 25. So there's 3 prime numbers so far. Makes 4 5s, make 5 5s. And remember, with the fifth root, again, we're looking for a group of 5. Well, 1, 2, 3, 4, 5. That's a 5 all by itself. Don't forget your squared. Your final answer, therefore, will be 25. And there you go. Good luck working with rational exponents and radical expressions, and have a great day.